students, welcome you all for the 5th class of force. See, already we have finished our 4 classes in the case of force, and also we have finished among the first part and second part. So today we are entering into the third part, last part of the force, that is uniform circular motion. So in today's class, let us discuss completely what you mean by uniform circular motion. In the next class, we will discuss about what you mean by centripetal force and centrifugal force. So before starting off today's topic, uniform circular motion, let me conduct a simple activity to make you to understand what is uniform circular motion. See students, this is a thread which has been taken. To one end of a thread, I have tied my pen. A simple pen. This activity you can even do in your home. So now what I am making it is that I am holding this thread at one end and start drilling it. Can you see that how I am drilling it? Yes, you can drill even it like this. So otherwise even you can drill in this way. So how? So what do you feel in this way? When you are looking it from here about the activity which I am conducting, you feel that the pen is moving in a circular motion. Is it not? It is moving in a circular motion. This is the simple activity which you can try in your home also. So out of this experiment, what is the relationship between today's topic, that is uniform circular motion? Let us find it. So now I am asking you a very simple question. When I was rotating the pen with the thread, can I rotate this pen with uniform velocity? Can I do that? See, last year in motion in one-dimension chapter, you have studied what you mean by velocity, what you mean by uniform velocity, what you mean by variable velocity or non-uniform velocity. What do you mean by uniform velocity? The distance covered by an object covers equal distance in equal intervals of time. Understand? So that we can understand what you mean by uniform velocity. So velocity is being a vector quantity. What do you mean by velocity? Velocity is nothing but displacement by time. The rate of change of displacement by time gives me the velocity. So velocity is having a direction and magnitude. So this is called as vector quantity. So now my question to you, can I rotate this pen with uniform velocity? Think it over. So my answer is no. My answer to it is no. It's impossible. It's impossible. It's impossible to rotate. It is impossible to rotate the pen with uniform velocity. With uniform velocity. So, to explain you further why I was not able to rotate the pen with uniform velocity, let me consider the still position. Let me consider 4 still positions of the pen when it is moving in a circular motion. Let me consider that. Consider 4 still positions. 4 still positions. Position of pen moving in a circular motion. So let me consider 4 then. So among the first one is, think that this is the first one, second one, this is the third one, this is the fourth one. Now in this 4 situations, let me consider first when the pen is here. This position taken as A. When you are rotating is that, see, understand the 3-dimensional image or even this image. When I showed you friend, it is being rotating in this way. Like how did I rotate it? I rotated anti-clockwise. Now even if you rotate clockwise, everything is one and the same. So when you were doing it, consider the pen was here in this position. So what is the direction of the pen when it is here? So no doubt the direction, no doubt that due to some force which is acting in the middle, it will be keep on moving in a when it is here, it will be trying to move in this direction. So you already know in your geography about this direction. So all this we consider this to be north, this is south, towards your right you call it as east, and this is east. So when the pen was in this position, what is the direction? The direction is west. The direction of the pen was towards west. Now consider it was here in the position B. So how does the pen move when it is here? The pen moves in the direction called as what we mean by south. Next, I will consider when it is here. Consider this position B. When it is in a circular motion. So what is the direction now? This is the direction of the pen. So it will be towards east. So at last I will consider it is here. Now it will be in this direction, that is north. I will consider this position to be D. See, based on the three positions, what did we understand in the case of a pen? In the case of a pen, we are understood when a pen is moving in a circular motion, its direction changes for every instant. Look at here, when it was in a position A, its direction was west. When it is in the position B, its direction is south. When it is in the position C, east. Position D, north. So what do you mean by it? There is a change of direction at every moment. So when the direction changes, what happens? When the direction changes, the velocity also changes. The velocity doesn't remain the same. When the velocity remains the same, the object should be moving in a straight path. Understand? But in a uniform circular motion, can an object move in the same direction? No. For example, it changes its direction of every instant. Not only about the positions A, B, C, D you can take. Even you can consider the position here. What is the position? If it is, for example, this all you know that like. So this you consider northeast, and this is southeast. This is northwest and southwest, right? So when it is here, it will be traveling in this direction. So if you consider that direction of the map, it comes under what? Southwest. So when it is here, it goes in this direction. It changes. So velocity changes at each and every instant. Understand? So this is what happens in the case of what you mean by uniform circular motion. That is the reason I have conducted the experiment. You can do that. If anything is moving in a circular path, you remember always its velocity changes at each and every moment. Why? Because the direction of the object which is moving in a circular motion does not remain the same. Understand? Now we will see that what is the conclusion we are drawing out of this for still position. Please copy down the same notes in your notes, whatever I am writing on the board. To the extra part, you can even refer the textbook. Please don't misuse the videos. So now let us see what is the conclusion I will draw from this. Now we will see what are the conclusions we have drawn from the activity which we conducted. So what are the conclusions? At every point, pen is changing its direction. Obviously, right? When you are rotating, see when you consider in circular motion, if pen was different positions you consider for a pen. These are the positions. These are the positions of the pen. What it is here, at every point, pen is changing its direction. So when it was here, it will be this. When it is here, like this. So this is how the pen will be keep on moving. See, in our next class of centripetal and centrifugal force also, we need the same explanation which helps us to know that. So we need to understand uniform circular motion very well. So here one thing you remember that what was making the pen to rotate? Why it didn't move in this direction? Because the force which was applied by me at the middle means in a hand I was holding some force. So when a thread was there, no doubt the thread was in between, right? So in a thread, what type of force is present? Remember, always when you take a string or thread, it will be having a tension force. What it is? A tension force. Due to tension force, what happens? The pen was keep on revolving there itself in a circular motion. For example, when you keep on rotating it, suddenly when it comes here, cut the string. You are not able to do it, but just imagine when you are rotating it, suddenly when it is think that it was here, at that moment when you cut the string, what happens? This pen will not come in between. This pen will go in this direction. The pen will just what it is in the west direction. Understand? But when the pen was here, it goes in this direction. So remember always to the force and direction, it will be how much? 90 degree. They will be always perpendicular to each other. See, if the pen is here, force will be acting here. So what is the angle between the direction and force? The angle between the direction and force will be always 90 degree. This is what you need to understand in the case of uniform circular motion. So at every point, pen is changing its direction. We came to know. See, when a pen rotates, direction of the pen changes at every instant. Obviously, when a pen is revolving around that, so what did we come to know? Direction of the pen changes at every instant. It's not only the four position. Every instant, the position, the direction which was here will not be there for the next. It changes. So direction and the force. What is the angle? I told you. The angle between the force and the direction will be always 90 degree at wherever it is. Understand? Next, changing direction implies changing velocity. This you have studied right from your 9th class motion in one dimension. Remember always. For example, if an object is keep on moving in a straight direction, if an object is keep on moving in a straight direction, what happens? The velocity of this curve does not change. Why the velocity does not change? Because it is moving in a linear motion. See, later part of the chapter we will see the difference between uniform circular motion and uniform linear motion. This is called what you mean by linear motion. So linear motion means linear or translational. What do you mean by that? First part of course we studied. If an object is moving in a straight path, so here velocity does not change. For example, you are playing a football match. You kick the ball from here to here. It was going in this direction, so it was having the same velocity until it reaches here. Your friend, opponent team, he kicked the ball in this, and now the ball changed this direction from this to this. Now you can call as there is change in its what? Velocity. Why? Because there was change in its direction. This is in the case of that. But what I am telling you is that in uniform circular motion, direction changes at each and every moment. If a direction changes at each and every moment, obviously we can tell there is change in its velocity. Understand? So hence in a uniform circular motion, remember always the velocity keeps on changing at any moment, and velocity is not uniform. It is called non-uniform. Now last, when a pen rotates, the velocity can never be uniform. This you have to be very carefully remember. So what did you understand by the total activity? When a pen rotates, it's not only pen, whatever thing you take, it is revolving around the sun, the velocity can never be uniform. For example, now Earth is revolving around the sun. Does the velocity of the Earth is same? No. Because since it is moving in a rotatory motion, its velocity keeps on changes. Even uniform circular motion is also called as what you mean by rotatory motion. Called as rotatory motion. Uniform rotatory motion. Understand? I hope you have understood till now what you mean by uniform circular motion in the activity. So before defining the uniform circular motion, we will consider one more type of scenario. In that case, I will consider a stone which is moving around a circular path, because now I have just explained you what is the role of velocity in the case of uniform circular motion. There is one more parameter which I need to tell you, very important in the case of uniform circular motion, that is speed. We need to bring speed, we need to bring the velocity. Then only the uniform circular motion gets completed. We will see that now how the role of speed is in uniform circular motion. Now let us consider a different scenario from the first case. In this case, I am considering stone moving in a circular path. Think there was a circular path. There is a stone which is moving in a circular path. Think this condition to be, this situation or this place to be A. This is B position. position B, this is position C, and this is position D. Understand? Now, a stone is moving in this circular path. I am considering the situation. Now, consider a stone which is being moving. This is a stone. Now, stone takes 0.1 seconds. The stone takes 0.1 seconds to move from A to B when you are rotating it. And think that. Again, when it is moving from B to C also, it is taking 0.1 second. Again, from C to D also, it is covering 0.1 second. From D to A also, 0.1 second. So that is the stone moving. The stone moving in a circular path. Stone moving in a circular path of time. For example, if you consider positions, AB is equals to BC is equals to what we have, CD is equals to DA. So all this covers is what? It is covering in 0.1 seconds. By this, what can you tell that? By this you can tell that the object is covering equal distance in equal intervals of time. Remember, so by this you can tell the stone is covering equal distance. Stone is covering equal distance in equal intervals of time. In equal intervals of time. No doubt here, the distance is same. In a uniform circular motion, what is the distance between AB? AB, if you consider just 10 meter, obviously BC also is having 10, this is also 10, and this is also 10. Now, what is the time it is being taken by a stone to move? The time taken by the stone to move is 0.1 second, 0.1 second, 0.1 second, 0.1 second. So, we can tell that the stone moving in a circular path of time 0.1 seconds. That is, the stone is covering equal distance in equal intervals of time. So, by this, what do you mean by distance by time? Equal distance in equal intervals of time. I am just telling you. So, what do you mean by distance by time? So, we already know distance by time gives us what we mean by speed, which is denoted with the letter V. Right? You have studied this in motion one dimension. Speed is what type of quantity? Speed is a scalar quantity because it is having only magnitude but no direction. Understand? So overall, in a uniform circular motion, what we understand is that, look here, in a uniform circular motion, you need to remember two things. Very important question which comes here is, in a uniform circular motion, which parameter is uniform, which parameter is non-uniform. They ask only this. So in a uniform circular motion, speed is uniform. Speed is uniform. And velocity is non-uniform. Velocity is non-uniform or variable. Okay, call it as non-uniform. Non-uniform or variable. Understand? This is the concept which I was trying to say from starting of the class. So what we mean by this uniform circular motion? In uniform circular motion, speed remains the same. Understand? But what changes? What variable? It's velocity. Why? Velocity is the rate of change of displacement by time. Direction, if it changes, velocity changes. But direction doesn't come in the case of speed. It's only the distance. Direction is not at all the matters because speed is scalar quantity. It has only magnitude, no direction. Hence, in a uniform circular motion, speed is uniform, velocity is not. Very important question it is. They will ask you, in a uniform circular motion, which is variable and which is constant. You can also put constant for uniform, variable for non-uniform. Now, after this, I hope you have understood. Now we will define what you mean by a uniform circular motion, and there are two criteria for a uniform circular motion to happen. There are two criteria which you know already. Again, we will write a question form. then we will see the differences between uniform circular motion and uniform linear motion. Now we will see the definition of what you mean by uniform circular motion or what you mean by rotatory motion. So how do we define uniform circular motion? Is when an object moves in a circular path. Obviously, first condition is object should move in a circular path with uniform speed. With uniform speed, its motion is called uniform circular motion. Only two conditions. What are those? Object should be moving in a circular path and also it should be moving in a uniform speed. Such motion is called as what we mean by uniform circular motion. Very important in asking definition. Other than the definition, conditions for uniform circular motion. Or then we ask you what is the criteria to an object possessing uniform circular motion. Always remember there are two conditions. First one, object should be moving in a circular path. Very important it is, object should be moving with circular path. So this is the first condition. I have marked here. This is the first criteria. If it possesses this, then the object is moving in a uniform circular motion. What is the second criteria? Object should be moving with uniform speed. Object should be moving with uniform speed. So if it satisfies these two conditions, then we can tell that object is moving with uniform circular motion or a uniform rotatory motion. So if it changes anything, like for example that if you take 4 positions, so time taken to move A to B is 0.1, but the time taken to move from B to C is 0.2 seconds means changes. What changes? Speed changes. If its speed changes, then it is condition 2 doesn't satisfy. It is not moving with uniform speed. Right. So we can tell it is a non-uniform circular motion. But when the speed and if the object is moving in a circular path with uniform speed, then we call it as uniform circular motion. I hope you have understood. Now we will see that last part of that. What is the difference between uniform linear motion and uniform circular motion? What is the first major difference? Speed is constant, but velocity is speed is constant and velocity also is constant. Where uniform linear motion. What do you mean by linear motion? Object which is moving in a straight line. Right? Object which is moving in a straight line. When object is moving in a straight line, speed also same, velocity also same. When does velocity changes? Velocity changes only when the object changes its direction. But in a uniform linear motion, speed also will be constant, velocity also will be constant, because in linear motion there is no change in direction. But what about uniform circular motion? In a uniform circular motion we have already seen speed is constant. Speed never changes. Speed never changes. That is what we call uniform circular motion. But what changes? Velocity changes. Why the velocity changes? In a uniform circular motion, at each and every place, at each and every direction, at each and every part, it is called direction is keep on changing. Direction changes. So if direction changes, we very well know that velocity changes. This is a major difference. You must remember. That is, speed is constant, velocity is constant in uniform linear motion. In uniform circular motion, speed is constant, but velocity is variable. Why the velocity is variable? Because in uniform circular motion, object changes its direction in each and every moment. Then what is the other one? The second one is, why the acceleration word come? Acceleration is 0. Hence it is called unaccelerated motion. This is also very important question that I am going to ask you. Why uniform linear motion is an unaccelerated motion? See, when do we bring the term acceleration? What do you mean by acceleration first of all? Acceleration means rate of change of velocity by time. Right? If there is change in velocity with respect to time only, we will get what you mean by acceleration. constant, if velocity itself is not changing, there will be no acceleration only, right? Hence we can call acceleration in the case of uniform linear motion is zero. Why acceleration is zero? Because velocity is constant, velocity is not changing. Change in velocity is acceleration. This is studied in motion in one dimension last year. Hence it is called an accelerated motion. So we can write an answer as in a uniform linear motion, the velocity is constant, that is it doesn't change its direction. Hence we can call that uniform linear motion as an accelerated motion. In your book bag they have given the questions. Please go through it. It's a very important ICSE question. But what about uniform circular motion? And even this question is important. They will ask uniform circular motion is an accelerated motion. Explain. By this time I know that you have understood. Why it is called accelerated motion? Because in a uniform circular motion, direction changes at every moment. And telling you, if direction changes, it means that velocity changes. If velocity changes, what does it mean? If velocity changes, it means there is acceleration which comes into a picture. If a velocity changes with respect to time, only acceleration comes into picture. Here the acceleration doesn't come into picture. The reason is the velocity is constant. If velocity is variable, we get what you mean by acceleration. Hence we can tell that the uniform circular motion is an accelerated motion. So this is how. Please in your book bag they have given starting 5 to 6 questions. Please go through that. You have to think very applicationally. Very rare type of questions they ask, very rare. They will test your knowledge of application questions. That is what ICSE is all about. So please go through the book bag question answers and solve some question papers. You will be understand the better. So by this today we will wind up the concept of what you mean by uniform circular motion. I hope you have understood better. Remember in uniform circular motion, speed is constant or uniform, velocity is variable or non-uniform. Understand the difference between is also very important. So in the next class we will go on explaining